All right, in 7.3, we're going to actually estimate a proportion using our confidence interval idea. Now, before you can calculate a confidence interval for a population proportion, you have to check two conditions. All right, so here's the two conditions you have to check. First of all, random. Did the data come from a random sample from the population of interest? So you're going to have to read the problem to see that it says it was a simple random sample. The other thing we have to test is the large counts condition, which we talked about previously, and that was where n times p hat has to be greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. If both those are met, both of those pass, then we know we can use the normal CDF curve, which helps us find a critical value called Z star. We'll talk about that. All right, we need it to pass large counts before we can move forward. So let's move on to the next slide. Now, we don't always go out 2 standard deviations in each direction. The number of standard deviations that we do go out when we estimate, remember that margin of error thing, that number of standard deviations is what we call the critical value. All right, and it depends on the confidence level. So write this definition down. A critical value is a multiplier that makes the interval wide enough to have the stated capture rate. So we want 90% of our intervals to match. That has to have a certain critical value. 95 has a different one. 99 has a different one. When the large counts condition is met, we can use the standard normal distribution to find the critical value for a specific level. Okay, and I'll show you how to do that. Now, another part of our margin of error is the standard error. It's an estimate of the standard deviation of our sampling distribution of p hat. We've already talked about this before. This formula should look familiar to you. This was our standard deviation of our sampling distribution. Okay, so in our margin of error, there are two parts. Okay, it's the critical value, and it's called Z star, times the standard error, which is this formula right there. Okay, so I'm going to show you how to find Z star. You already know this formula right here, so you find those two and multiply them, and that is your margin of error. Remember, that is what we add and subtract to our point estimate to get our interval. So here it is. Write it down. When the random and large counts conditions are met, a whatever percent confidence interval for the population proportion P is the point estimate plus or minus the margin of error. So all of this right here is the margin of error. Okay, we just discussed that. So write this down. Critical value is Z star right there. I'm going to show you how to find that. In your calculator, you're going to want to know these keystrokes. So write them down. I'm going to show you how to use them on the next slide. You're going to go to stats, then over to tests, and there's a lot of tests in there. You want test A, which says a 1 proportion Z interval. Okay, so let's look at some examples. Latoya wants to estimate the proportion of all students at her large boarding school that like cafeteria food. She interviews a simple random sample of 50 students, of the students living in the dormitory, and finds that 14 of them think the cafeteria food is good. All right, so check to see if the conditions are for calculating an interval for P are met. Okay, so the first one is random. Do we know if random is done? Yes, it says it right here. So the way you would tell me this is you say random, you say the simple random sample where n is 50 students. And that's all you have to do. You just have to reference what the problem told you. Now for large counts, remember, it's n times p hat has to be greater than or equal to 10, and n times 1 minus p hat, p hat, has to be greater than or equal to 10. Now, it doesn't give you p hat. You've got to figure that out. So p hat is the proportion of students that like the food. Well, she said 14 out of 50. Right? So you're going to put that in your calculator and get the decimal version of that. And again, it comes out to 0.28. So that's my p hat value. So my sample was 50. So I'm going to do 50 times 0.28. And I get 14, just like I thought. And that's greater than or equal to 10, so that passed. Then I have to do 50 times 1 minus 0.28, and I get 36. That's greater than or equal to 10, so I show that. All right, so I've checked both conditions. This is the kind of work that you need to show me. You show me you did n times p hat is equal to whatever, and it's greater than or equal to 10. A lot of people forget this portion of it, but I want to make sure you do that every time. And the 10 is always the same. 10 never changes. Okay? Now, looking at number 2. Find the critical value for a 90% confidence interval. All right, so here's what's happening. Think of your normal curve, and I want 90%, okay? So we need to figure out, okay, what are these values right here that cut off the middle 90% of my curve? Well, if you think about it, the whole curve adds up to 1, right? And if I subtract 90%, I'm left with 10%. But I have two ends of the graph. I have a left tail and a right tail. And I divide that 10% by 2, and I get 0.05. So I know the area over here is 0.05, and the area over here is 0.05. So what I'm going to do to find this z value right here is use my good old inverse norm, and it's going to ask me for area. So I'm going to say 0.05, and then it's going to say the mean and standard deviation. Well, the mean is always going to be 0, and the standard deviation is always going to be 1. So on my calculator, it looks like this. Second bars, inverse norm is number 3. The area is 0.05. Leave mu and sigma alone. Hit enter. And you get negative 1.645. Okay? So, negative 1.645. Now, honestly, we don't care about the negative, because if we had done it over here, found this z star, we would have gotten positive 1.645. So z star is the absolute value of whatever the calculator gives you. So it's just going to be 1.645 for a 90% confidence interval. And you would follow that same process to find any other percentage. All right, so here's the scenario again. We've already talked about, we figured out that our p hat value was 0.28. We found our z star value as 1.645. So this is to calculate a 90% confidence interval for the proportion of students at her school that like the cafeteria food. All right, so remember the formula. It says the point estimate plus or minus z star times the standard error formula. Remember? So my point estimate is this guy right here, 0.28 plus or minus, that's what that symbol means, 1.645. And the standard error is that big square root we've used before. We use 0.28 times 1 minus 0.28, and we divide it by our sample size, which was 50. Now, this is a lot to type in the calculator. That's why I want you to use the keystrokes here. So I'm going to show you what the calculator is going to ask of you. This is the work, however, you need to show me, and then you can put it in the calculator to get the actual values. So in your calculator, in my calculator, I'm going to go to, I'm going to go to Stat, Test, and then I'm going to scroll down till I get to Test A. There it is, 1 proportion z interval. Now, X is the number of students that she thought that the cafeteria food was good. Well, in this case, X was 14. N was how many samples did she take. C level, that's our confidence level. We want a 90% confidence interval, so we put 0.90, and then we hit calculate. It does the rest of it for us. You need to write the formulas out like I've shown you, but it does the rest. So if you look at this, this is giving us our interval. It goes from 0.176 to 0.384. So my answer is 0.176 to 0.384. All right. That is our confidence interval. So what does this confidence interval even mean? Well, it means that we're 90% confident that the true percentage of students who like the cafeteria food is between 17.6% and 38.4% of students. All right, that's where we're going. We're going to interpret these intervals in the next lesson, but right now I want you to focus on just calculating them.